Okay, this is going to be our first vodcast of the year, and we're going to cover Unit 1, Lesson 1.1. And you'll see a typical format throughout the year as you watch the different vodcasts. You'll see the unit, the lesson, and the title of the lesson. These lessons do correspond to both of your notes packets and the practice packets. So as we are working through the units, working through the notes packets and the practice packets, use the corresponding lesson in your notes and practice packets. So let's get started. I'll talk a little bit about the process in this first one or two, but then after that we will, you'll pick up on it and you'll get the way I do this. Alright, so let's talk about chemistry for a little bit. Chemistry, first of all, is the study of matter and the changes that matter undergoes. This is very important because there are other science classes such as biology and physics and earth and space science, but what we do is we look at matter, and matter is anything that has mass and takes up space or has volume. So when we talk about things that have mass and take up volume, we're talking about the things on the periodic table. So basically all of the stuff that's made up of the elements on the periodic table are what we study when we study chemistry. And you can see here there's a diagram of just all kinds of stuff. So oftentimes people will refer to matter as stuff. There's a big difference between matter and energy, and we will talk about that a little bit later in the year. Before we get into too much about matter and that, let's talk about basically what science is. People often hear these phrases, well, scientist says or science says, and people have this idea that there's some organization out there that is the science organization that dictates the rules of what we understand. Science is nothing more than a problem-solving process. And there are steps in that process. So when we say scientists say, what that means is somebody followed certain procedures to come up with explanations for phenomena. And that's all science really is. So that method, which I'm sure you've all heard of, is what we refer to as the scientific method. Now, if you've taken 5 different science classes, you've probably gotten anywhere from 3 to, 8 steps in the scientific method. But really there are 4 basic steps, and then you can break these into different steps, or sub-steps if you want to call it. First of all, you have to observe some sort of phenomenon. You might drop an object and it might fall to the ground. And you might drop another object and it will fall to the ground. And you'll drop another object and it'll fall to the ground. Well, what you've noticed is things always fall in one direction. They don't fall in an up direction or a sideways direction. So what you want to do is come up with some sort of hypothesis or an explanation for why or how that object always falls towards the ground. Now, oftentimes a hypothesis is described as an educated guess. We are not going to say that because as soon as you put that word guess in there, it sounds like you're just saying, well, maybe it's this sort of thing or maybe it's that sort of thing. What we're going to do is use the word explanation. So your hypothesis is your explanation of why or how that phenomenon is taking place. Once you come up with your hypothesis, the fundamental part of the scientific method is experimentation. If you don't run experiments, you are not following the scientific method. Now, there are some modern scientific theories out there like string theory, which is very difficult, if not impossible, to experiment with. But there are, well, I don't want to say there are exceptions. For it to be considered the scientific method, you have to be able to run testable experiments. So what you want to do is design your experiment, run your experiment, collect your data through observations, And then once you do that, you're going to come up with either a scientific theory or a scientific law. And we'll talk about these two things in a little bit more detail. Okay, so let's use Newton's law of gravity, for example. As we said, things fall in a certain direction, and they seem to fall in that direction at a constant speed. So the observation here is that things are going to fall at 9.8 meters per second squared. And again, if we were in a physics class, we would talk about this in a little bit more detail. So our hypothesis is that regardless of the mass of the object, it will fall towards the Earth at 9.8 meters per second squared. So a fairly simple experiment would be get two objects of different mass, let them fall from a certain height to another height, measure the time it takes to go from point A to point B, the distance from point A to point B, and then you can measure the velocity at what those objects fell. Now for this case, we're going to develop what we call a law. And a law simply states what happens in the natural phenomena. Law of gravity says objects fall, well, on the Earth, objects fall at 9.8 meters per second squared towards the center of the Earth. The difference between a law and a theory: laws state what happens, theories explain why it happens. And that's a very important distinction which we will talk about throughout the year. Alright, as you collect your data, you're going to sometimes graph your data, sometimes not. But let's talk about when we graph our data. As you all know, a graph is made up of an x-axis and a y-axis. And your dependent variable or your responding variable is always going to go on the y-axis. And what you might want to remember is that the thing that you are measuring, if you're measuring the mass, if you're measuring the temperature, if you're measuring the volume, whatever you're taking your measurement for, that is what's going to go on your y-axis. And we refer to that as the dependent variable. The independent variable, or the one you manipulate, goes on the x-axis. So for example, let's say we are changing the temperature of a solution, and then we are going to measure the pressure of that solution. So as we change the temperature, what happens to pressure? So the thing that we are manipulating or changing goes on the x-axis. The pressure that we are measuring, we're going to measure on the y-axis. So you might get some sort of data grid that looks like this. And we'll talk about graphing in much more detail a little bit later. But you do want to know the dependent and the independent variables and which axis they go on your graph. Alright, as you take your observations, you're going to have two types of observations: quantitative observations and qualitative. And this is very simple. Quantitative observations have a number. That's not a hashtag symbol. It's a number symbol and a unit. So you might measure 9.1 grams. That's your number, that's your unit. Scientists like quantitative measurements because numbers are not ambiguous. In other words, 9.1 is 9.1. And again, we will talk about this in much more detail also later. Qualitative measurements are subjective. So what that means is, they're subjective. So they are based somewhat on opinion. So qualitative observations tend to be heavy, light, smell, color, etc. Quantitative observations are objective. So objective, there is no discrepancy as to the number. Subjective can be there can be some discrepancy in the observation. So for example, the book is heavy would be a qualitative observation. The book has a mass of 900 grams would be a quantitative observation. So quantitative, qualitative. The tub is as large as a gas can, qualitative. The tub has a volume of 3.5 liters. Number plus unit equals quantitative. Alright, so that's what we're going to talk about with the scientific method. You should know the steps of the scientific method. You should be able to pick out those steps from scenarios illustrating the scientific method. You should be able to graph your data correctly with the thing that you are measuring on the y-axis, the thing that you are manipulating on the x-axis, and you should be able to describe your observations that you are taking, whether they're quantitative observations or qualitative. These videos tend to be about 10 minutes long, so you can gauge your time. And again, you will pick up on the format of how we do this as we move through the year. Very good.